So let's continue with the advantages of stainless steel. So first we need to show what is stainless steel. So as the name, you can see in the name, it is stainless. Stains means the stains of corrosion or some other cargoes. Why we will see, because it's a layer of stainless steel or chromium oxide which leaches out slowly, and with that washing and all the stains also uh, generally they don't come. First the cargo will get slipped through, so the stains will not come, and even if they come, then it will get leached out, generally, not always, but generally. Now, as we know, stainless steel is like inert, it does not react with most of the cargoes. Then it does not uh, gets corroded easily, even with highly corrosive chemicals like sulfuric acid. So this is the advantage, because generally the steel which gets corroded is mild steel, but here, because we have a layer of what you call uh, stainless steel, then that's why we don't have this corrosion on stainless steel. And also for cargoes which need high standards of purity, as we talked, that like at home using utensils, or for milk, these people are using, milkman is using stainless steel or aluminum containers. So on ship also many high expensive cargoes, hexene and methanol and cyanides and all are carried. So these require very high standards of purity. They should not get contaminated or with the reaction with the tank coatings. So we need stainless steel. And then chromium oxide as a layer on the top of this what you call stainless steel. It's a very thin layer, around 1 millionth of of this. It's in microns. But just with this layer, it makes the stainless steel quite shiny, and like you can see the glance and glow is there, and it's like free surface. The cargo does not sticks to it. So it forms a passive layer. What its property is, the chromium is that it reacts with in the presence of oxygen, air, or moisture, and it becomes chromium oxide. And chromium is very inert or non-reactive with chemicals. So these chemicals are not getting contacted with the actual steel, and therefore there will be no contamination and corrosion. Uh, but this layer, if it is damaged because of abrasion of the cargo or corrosion or some fittings or cracks or any damage, then it will not act as a stainless steel. It will act as a mild steel, and then there will be a lot of corrosion and problem. So we will see how these problems are occurring and how to solve them. Now, there are two types of stainless steel which we can have. Either the full tank metal is made up of stainless steel, or you can have a coating of a stainless steel on the mild steel, which is called cladding. So if we have a full metal of stainless steel, full metal of stainless steel is that means it contains around a lot of alloys, 10% of chromium oxide and 5-10% of other alloys, metals. Each different composition is there. But then it will be very heavy. It will be very tough, very hard, but it will be very heavy. As you can see, like if you buy utensil outside, stainless steel cookware will be much expensive, and normal mild steel will be quite cheap. So it will be very heavy, and then because it's heavy, you will lose the cargo dead weight, and that also will cost the owner and charterers money all throughout the life of the ship. So it's very expensive. So next option is we have cladding. Cladding means the coating of stainless steel on normal mild steel. And main thing is we need the coating because you don't want the cargo to come in contact with the steel which is causing corrosion. So our purpose is also solved, and the tank is also the steel is not also very heavy, but then it's not very strong also. So cargo will not stick on stainless steel; it will flow freely. But then there are some main issues with the stainless steel. So first is the presence of ballast water in the adjacent tank. So when we are doing tank washing, we can see that this chloride or seawater, it comes in contact with this tank stainless steel, and stainless steel is a very bad affinity for seawater or chloride. It gets very easily damaged or corroded or affected with the seawater and chloride. So this is called, actually what is called chloride pitting. Pitting means the corrosion and damage to the coating is taking place in small pits, small holes. So these holes and all, they look from outside the full tank, you will see from a distance full stainless steel. But when you go close and see, this stainless steel is getting damaged from inside, and this chlorides fittings, the corrosion it's making is very very deep inside. It's like in your teeth, in your tooth, all the teeth are looking good, but one place you will have this some worm or bacteria, and it will be deep rooted, for which you have to remove all the tooth. Same way, this chloride pitting is very deep rooted, and many places you will see weeping of the cargo. It's a rust to brownie color water, rust weeping is there. And because of this, the cargo can contamination can also take place. The cargo, it will react with the cargo, the steel, and also there can develop cracks and some things. So the tank coating will damaged, and then there is also a problem that if you are loading sulfuric acid or something, if this coating is not properly done, it's not proper now after fitting is there, then the cargo again will react with the coatings or mild steel, and many times if it is sulfuric acid quite pure, it's happened on ships that you will see a lot of patches of brown patches like corroded material. Not only in the tanks, because of the gas, you will see outside many places on the accommodation decks also behind, and full ship everywhere you can see that there are patches of what you call corroded material. Even you can see in the lifeboat cradle stainless steel part or other metal parts. Then next issue is bimetallic corrosion. Bimetallic corrosion is mild steel, uh, what you call like stainless steel, as we discussed. It's like a cladding, so it is a layer of stainless steel on the mild steel. Now, when these two metals are joined together, so because of these two metals are joined, and you have studied in galvanic cell, so one side we have ballast tank and one side we have cargo tank. So just because of the presence, these two metals are in contact, galvanic cell is present, or if there are some cracks or something, this ballast water is there, and it will make seawater is electrolyte, and it will make a galvanic cell, and there will be lot of corrosion. And you will see after some time that there is a break in the bond between this mild steel and stainless steel, and full layer is corroded. So very lot of strength is lost. Then next, as we discussed, the pitting of stainless steel, which is again due to this ballast water. And in most of the ships, that's why after chemical on chemical tankers, after washing with seawater or chemicals, whatever we are doing, in last always we wash with fresh water, all the lines and all, because there have been in some ships that the same two sister ships were coming out of the yard, same time delivered and same company and all, same type of tank laying procedure they were following as by the owners. But one ship was in Singapore and others worldwide. So near Singapore and all, they didn't got that much time and they were not doing freshwater wash. And after a few months, they found that all the pipelines on the deck everywhere, they were leaking badly with uh, like a strainer. All cargo is falling down. So pitting of stainless steel is very dangerous. Don't think that stainless steel is there, so you will not form any rust. Like you see med guards of your cycle many places, especially a few years before. So they were like shiny, made up, looks like made up of stainless steel, but it's just a layer. And after some time, you see they are also getting rusted. So stainless steel, if it is full metal of stainless steel, then it might avoid and get rust, but it's very expensive. And the layer of stainless steel generally gets also damaged. So this planning of what kind of cargoes we are going to carry and how we can take care of this is very important by the owners. So the solution, what is the solution for these problems and issues of stainless steel? First is either we can have an independent tank. Independent tank, as we know, it's not connected to the ship's hull and structures. So if there is what you call some cracks or something, it will not crack or damage the other parts of the ship. That's not normally done. Then we can have either a void space. If we have a void space between the ballast tank and the what you call ship's cargo tank, then the ballast will not come in contact, and then there will be not that much pitting and corrosion. Otherwise, there is some typo coating or something of the tanks we can do. Also, there is a process of renewing the layer of the stainless steel. Passivation, we will see. Then we have this layer of stainless steel, which is on the mild steel base, that is called cladding of the steel. So since it's a very small thin layer in microns, so it's very economical to have this type of steel instead of having full tank of what you call stainless steel metal and all. And the other side of the coating is this mild steel is used for having ballast tanks, which is in load ballast in the other side of the tanks, which is called DB tanks or wing tanks, topside tanks. Now, as we know that normally stainless steel is an alloy, and once the metal is mixed with other metals, which is called an alloy, so the alloy generally have less property of they have less strength than the pure metal. So because of this, especially with stainless steel, if you see in chemical tankers, if you see the vertical ladders or the Australian ladders, circular ladders, you see the steel bars of these ladders, they generally can see many cracks or something. So we have to be very careful while doing inspection in this tank. They require a lot of close inspection to see where the cracks or fittings or this corrosion is taking place. Many times you will see the nuts bolts from some pipelines or something is coming down and falling down. Now it's very dangerous because if they go in the pump's impeller, they can damage. But generally it's little bit heavy, and it's been happened and observed sometimes that the bolts have fallen down, hexagonal nut bolts size 30, and they just keep churning around the impeller and the bell mouth and all. Like it was seen that this nut bolt became like a full donut, smooth, round, and because of the churning and this thing. But luckily, they didn't go into the impeller, which is like generally does not happen because of the centrifugal force around it or something, and they are heavy also. So how this stainless steel is bonded with this metal mild steel? It's called a thermite bonding, or it's a special type of welding or brazing, which is done in the manufacturing process itself. It's a special order bulkheads which are done there. Now, most of the chemical tankers, you will see that they are sometimes they're taking partial cargo. So always they try to have maximum ballast, like maximum stability, because small ships also and there's a lot of vibration. And with vibration, we see we can develop cracks. So solution is take maximum ballast always. And next after that is a process of passivation, which is the renewal of chromium layer. So in that we have a pickling liquid, and this pickling liquid is a very long and strenuous process.